Welcome to EDU World Space.
So we're asked about two spheres that are 1 meter apart. So we've got let's make it a red sphere and a green sphere. And the center to center distance, guess I should make black here, is 1 meter. They're made of the same element, which means they'd have the same density. And the gravitational force is 1 Newton. So force equals, I'm just going to write the generic equation, gm1 m2 over r squared, but we know r is 1. Well, the volume of a sphere is 4/3 pi r cubed. But that's not the same r there. R, let's say r of red sphere. Now, it does not say that the spheres are the same radius. Okay, so but if we take the volume times the density, which is the same for the red one and the green one, then that's going to give us the mass of the red one. Likewise, the mass of the green one is going to be the same, but you just substitute in Rg. So, force equals and we're told that force is 1 Newton. So force equals G M red, which would be 4/3 pi r red cubed times the density, Rg, which is 4/3 pi Rg cubed times the density over r squared. But we also know that r red plus Rg, since they're not going to interfere with each other, has to be less than or equal to r. And I think that's going to be our problem, that there's no way that you would have enough mass in these spheres. So let's go ahead and simplify this. I'm going to multiply by r squared on both sides, f r squared. Now I'm going to divide by g on both sides also. F r squared over g is 4/3 times 4/3 is 16/9. Pi squared rho squared r cubed r g cubed. So what I think I'm going to do is I'm going to set the density to the maximum density of any element on the periodic table. All right, I Googled it, and it tells me that osmium is the densest element on the periodic table at 22590 kilograms per cubic meter. So I'm going to set that density. And I'm going to solve this whole equation for RR cubed times RG cubed. So it's going to say RR cubed RG cubed equals 9/16 F R squared over G pi squared rho squared. And now I'm going to put this into Desmos.com graphing calculator. So 9 times F. Let's look at what F was. 1 times R. Let's look at what R was. 1 squared, which is still 1, over 16 times G, 6.67, times 10 to the negative 11th power, times pi squared. Pi squared times rho squared. 22590 squared. Okay, that gives me interestingly enough, and I'm wondering if my answer makes sense, 1.67. Okay, so that's 9 times 1 times 1 squared over 16 G okay times pi squared times rho, which is 22590. Just making sure I don't have a mistake there. Okay, I guess this does make sense because the 22,590 squared kind of cancels out the magnitude of G at the negative 11th power. And so 1.67. All right, so if I take the radius of the red one times the radius of the green one cubed, it equals 1.67. I guess I could take the cube root of both sides. So let me go ahead and do that. That gives me that R times RG is 1.19. The radius of the red one times the radius of the green one is 1.19. but RR plus RG must be less than or equal to 1. So let's write that down here. Okay. So that means that RG must be less than or equal to 1 minus RR. And RR is 1.19 over RG, right? So let me put these two together. RG has to be less than or equal to 1 minus 1.19 over RG. Now we know that RG is a positive number. So if I multiply everything, if I square everything, if I multiply everything by RG, I get RG squared is less than or equal to RG minus 1.19. And so moving everything to the left side, RG squared minus RG plus 1.19 must be less than or equal to 0. RG squared minus RG plus 1.19. All right, so I'm going to go to graphing calculator and I'm going to graph this. X squared minus X plus 1.19. I'm going to write Y equals. And I'm going to reset I'm going to make my X and Y axis go from negative 10 to 10. And Y axis is going to be negative 10 to 10. Oh my goodness. Come on. There we go. Negative 10 to 10, negative 10 to 10. All right. That gives me, finally, on a scale from negative 10 to 10, something that looks like this. Where the vertex is like right there. This is never less than or equal to 0. So our mass isn't high enough. And let's just see here. Our mass was, or our density isn't high enough. Our density was 2